mechanical properties of solids. So we think of like this, just observe. If I have this dusting cloth in my hand, then I press it like this. What happened to its shape? Changed. Even if you take a sponge, if you press it, its shape changes. The force what we apply to change the shape, can you generate a name for it? ನೀವೇ ನಾಮಕರಣ ಮಾಡಿ ಮಕ್ಕಳ, ನೀವೇ ಪುರೋಹಿತರಾಗಿ. ಈಗ why don't you take the charge of a ಪುರೋಹಿತ್ to name? Naming ceremony ನೀವು ಮಾಡಬೇಕು ಮಕ್ಕಳ. ನಾನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ, this cloth is in my hand, I am applying it, its shape is changed. Can you name that force what we are applying here? Can you give a special name for that? ನಾನು ಹೇಳಿದೇನೋ, ಇಲ್ಲಿದೆ ಆನ್ಸರ್ ಇಲ್ಲೇ ಗೊತ್ತಾಗ್ತಿದೆ. ಇದು ಹಿಂಗಿತ್ತು, ಶೇಪ್ ಚೇಂಜ್ ಆಯ್ತು, ಕೈ ಬಿಡ್ಬಿಟ್ರೆ ಮತ್ತೆ ಇದಕ್ಕೆ ಬರುತ್ತೆ. ಹಾಗಾದ್ರೆ ಶೇಪ್ ಚೇಂಜ್ ಆಗೋ ಫೋರ್ಸ್ ಏನಂತ ಹೆಸರಿಡ್ತೀರಪ್ಪ? ಶೇಪ್ ಚೇಂಜ್ ಮಾಡೋ ಫೋರ್ಸ್ಗೆ ರೌಡಿಗಳ ಭಾಷೆಯಲ್ಲಿ ಹೇಳಿದ್ದಾರೆ, ನಮ್ಮ ಕನ್ನಡ ಪಿಕ್ಚರ್ಗಳ ರೌಡಿಗಳು ತೋರಿಸೋ ಶೇಪ್ ಹತ್ಬಿಡ್ತೀನಿ ನಿನಗೆ ಅಂತ ಹೇಳ್ತಾರೆ ಅಲ್ವಾ ದೀಕ್ಷಿತ್? ಅದನ್ನೇ ಅದೇ ತರ ಅಂತಾರೆ. ಇಲ್ಲೇರೋ ಒಂದು ಹೇಳಿದ್ರೆ ಯಾರು ಹೇಳಲ್ವಾ? ವಾಟ್ ಇಟ್ ಈಸ್ ಡೂಯಿಂಗ್, ಇಟ್ ಈಸ್ ಚೇಂಜಿಂಗ್ ದಿ ಶೇಪ್. ಚೇಂಜಿಂಗ್ ದಿ ಶೇಪ್ ಅನ್ನೋಕೆ ಇಂಗ್ಲಿಷ್ ನಲ್ಲಿ ಒಂದೇ ವರ್ಡ್ ನೋಡಿ, ಬ್ಯೂಟಿಫುಲ್ ಕ್ವಿಜ್ ಇದು, ಡಿಫಾರ್ಮಿಂಗ್ ಅಲ್ವಾ? ಡಿಫಾರ್ಮಿಂಗ್ ಅಂದ್ರೆ ಚೇಂಜ್ ಇನ್ ದಿ ಶೇಪ್. ಅಲ್ಲಿ ಒಂದೇ ವರ್ಡ್, ಡಿಫಾರ್ಮಿಂಗ್ ಫೋರ್ಸ್. ಸೊ ವೆನ್ ವಿ ಅಪ್ಲೈ ಅ ಡಿಫಾರ್ಮಿಂಗ್ ಫೋರ್ಸ್, ಶೇಪ್ ವಿಲ್ change. Okay. From there we start with start our journey in the mechanical properties of solids. So first thing what I told you now, deforming force. First thing. That is a force applied to change the shape. That's a force applied to change the shape. Applied to change the force, shape. After this, observe. Again, our dusting cloth will come to our help to learn the physics. This is the thing. If I press it, it changes the shape. If I leave it, it comes back to normal shape. So that property which tries to bring it back to normal shape once the deforming force is removed. So I am pressing it like this. I am applying the deforming force. So its shape is changed, deformed. If I leave it, it comes back to original shape. That property which brings it back to, tries to bring it back to normal shape or original shape, may be called as, now it's again a challenge. Oh, deforming a beautiful like Prajwal is telling me, reforming Allah. ನೀವೆಲ್ಲ 10th ತನಕ ಸೋಷಿಯಲ್ ಓದ್ಬಿಟ್ಟು ಸೋಷಿಯಲ್ ರಿಫಾರ್ಮೇಶನ್ ಅಂತ ರಾಜಾರಾಮನ್ ರಾಯ್ ಅಂತೆಲ್ಲ ಓದ್ಬಿಟ್ಟು ಅದೇ ರಿಫಾರ್ಮಿಂಗ್ ಇರುತ್ತೆ. ಇಲ್ಲ, ಇಲ್ಲಿ ಬೇರೆದೆ ಮಕ್ಕಳ. ವಾಟ್ ದಟ್ ಪ್ರಾಪರ್ಟಿ ಮೇ ಬಿ ನೇಮ್ಡ್, ವಾಟ್ ಈಸ್ ಹೆಲ್ಪಿಂಗ್ ದಿ ಆಬ್ಜೆಕ್ಟ್ ಟು ಕಮ್ ಬ್ಯಾಕ್ ಟು ಇಟ್ಸ್ ಒರಿಜಿನಲ್ ಥಿಂಗ್. ಅದು ಬಹುಶಃ ಗೊತ್ತಾಗ್ಲಿಕ್ಕಿಲ್ಲ. ಐ ರೈಟ್ ದಟ್. ಈಗ್ಲಾರು ಒಂದು ಪದ, ಒಂದು ಅಕ್ಷರ ಹೊರಟದೆ, ಇ. ಇ ಮಧ್ಯದಲ್ಲಿ ಎರಡನೇ ಅಕ್ಷರ ಬರೀತಿ, ಎಲಾಂಗೇಶನ್ ಆರ್ ಎರಡನೇದು ಹೇಳ್ಬೋದು, ಎಲಾಸ್ಟಿಸಿಟಿ ಆರ್ ಎಲಾಸ್ಟಿಕ್ ನೇಚರ್. ಎಲಾಸ್ಟಿಸಿಟಿ ಅಂದ್ರೆ ವಿಚ್ ಟ್ರೈಸ್ ಟು ಬ್ರಿಂಗ್ ದಿ ಆಬ್ಜೆಕ್ಟ್ ಬ್ಯಾಕ್ ಟು ನಾರ್ಮಲ್. ಓಕೆ, elasticity is the thing. Now, elastic force or elastic property of the object makes it to come back to original shape. In this world, in fact, we can classify solids into two groups, rigid and elastic, and one more, plastic. Three terms. All the solids can be come under one of the three categories: rigid, elastic, plastic. Plastic is not the one what you learn in chemistry, polymers. what we use nowadays more often for all many things. Plastic carry bags are there nowadays. Somewhat we wanted to avoid them. Not only that, plastic chairs are there, plastic tables are there. Everything is in plastic. But that plastic is not this one. That's something we think of it. First of all, we said rigid body. We said long back in the 7th chapter. What is it? I started this chapter like that only. Say change in the shape or distance between the 2 points in the object is not observed even under the action of force, then we call that as rigid body. We learned it in the chapter 7. Elastic, just now we learned. It is an object which regains its original shape once the deforming force is removed. What is plastic? Once you apply a deforming force, it retains its change of shape. Change of shape. For that matter, we go for a beautiful thing. Say, ಈ ಸರಿ ಯಾವ ಹಬ್ಬಗಳು ಸರಿಯಾಗಿಲ್ಲ. ಇನ್ ಗಣೇಶ ಚತುರ್ಥಿ, ಗಣೇಶನ ಮೂರ್ತಿಗಳನ್ನೆಲ್ಲರೂ ತರ್ತಾರೆ. ಲಾಸ್ಟ್ ಇಯರ್ ಇಂದ ಇರೋ ಒಂದು ಏನಪ್ಪ ಅಂದ್ರೆ, ಲೆಟ್ ಅಸ್ ನಾಟ್ ಯೂಸ್ ಪ್ಲಾಸ್ಟರ್ ಆಫ್ ಪ್ಯಾರಿಸ್ ಗಣೇಶ ಆರ್ ಎಲ್ಸ್ ದಿ ಕಲರ್ಡ್ ಗಣೇಶ ಅಂತ. ಕಲರ್ಡ್ ಆಗ್ಲಿ ಪ್ಲಾಸ್ಟರ್ ಆಫ್ ಪ್ಯಾರಿಸ್ ಬಿಟ್ಬಿಡೋಣ. ಕಲರ್ಡ್ ಗಣೇಶ ಆಗ್ಲಿ ಕಲರ್ ಇಲ್ದಿರೋದಾಗ್ಲಿ ಮಾಡೋದು ಜೇಡಿ ಮಣ್ಣಿಂದ, ಕ್ಲೇ, black soil or some clay. That black soil, when you add water, becomes plastic. ಏನು ಸರ್ ಹಾಗಂದ್ರೆ ಅಂತ ನೋಡಿ, when they make Ganesha idol using clay, ಸುಮ್ಮನೆ ಹೀಗೆ ಸೊಣ್ಲಿಂಗ್ ಇದೆ, ಅದು ಗಣೇಶ ಹಿಂಗ್ ಮಾಡ್ಕೊಂಡ್ ಬರ್ತಾನೆ. ಆ ಶೇಪ್ ಹಂಗ್ ಉಳಿದೆ ಹೋದ್ರೆ ಮತ್ತೆ ಅದು ಮಣ್ಣನ್ ಮುದ್ದೆನೆ ಆಗ್ಬಿಟ್ರೆ one cannot do Ganesha idol. So ಅಲ್ಲಿಗೇನಾಯ್ತು, once that artisan gives a shape to that, ಯಾವ ಶೇಪ್ ಕೊಡ್ತಾನೆ ಆ ಶೇಪ್ ಅಲ್ಲಿ ಉಳ್ಕೊಳ್ಳುತ್ತೆ ಕ್ಲೇ, ಅಂದ್ರೆ that retains the shape. The shape is given because of the deforming force. That shape is retained 100%. And such type of objects are called as plastic. That means once the deformation takes place, their shape change is permanent. They will not come back to original shape at any cost. That is what we mean by plastic. So with these things, rigid, elastic, plastic. 3 things: rigid, elastic, and plastic. So with these things now, one thing of astonishment in this world, no object is perfectly rigid, no object is perfectly plastic, no object is perfectly elastic. We go for the plastic at the end, no need to bother. First 2 are important. No object is perfectly rigid, no object is perfectly elastic. In one of the classes, say not for you, in some years back, when I was talking on the mechanical properties of solids, one student asked me, I told him, stone is an example for rigid object. Sir, it is going to be crushed when we apply more force. Definitely, it shatters into pieces when you apply large force. So that's a good idea. He thought of it. Their shape changes again because of the properties which are not perfectly rigid. If you have a perfectly rigid body, no question of shape change, no question of breaking, nothing like that. That is about rigid body. Elastic, just now we said, any object which can regain its original shape once the deforming force is removed, that is elastic. But no object is perfectly elastic. In this world, no object is perfectly elastic. In fact, all the objects are mixture of these two, rigidity as well as elasticity. In some of them, elasticity is more. In some of them, rigidity is more, like that. So it is like this. If no object is perfectly rigid, no object is perfectly elastic. It's a mixture. Okay, whatever it may be the thing. Now, once we learned these definitions and all those things, we start the next idea like the systems. Some definitions again. Deforming force we learned, elastic, rigid, and plastic objects we learned. Say, once deforming force is applied, to an elastic object, to an object. What will happen? We want to see. For that, you just imagine a rubber band. Keep between two fingers like this and expand it like this. If you expand it like this, what is the feeling on your hand? Just like what I said in case of spring, long back, in the loss of motion case. Say once we pull the spring also, even rubber band also, spring. Once we pull the spring like this, what is the feeling on our hand, which is pulling it? Spring tries to pull our hand back. That means there is a opposite pull we feel on our hand. What is that I called there? Can you remember what is that force applied by the spring on our hand called? It restores. We said it, no? Spring force is a restoring force because it tries to bring the spring back to its normal length, either compressed or expanded, is brought back to original shape. Therefore, now, once an object gets deformed, say right, I take a wire, for example, a wire. I have written much blown up, big figure. And we apply a force to pull it down. We apply a force to pull it down. Then it expands. There's an astonishing thing. You will learn the answer for that most probably in next class. But before that, I will ask you a question. Among rubber, elastic rubber, what you have, rubber band, and steel wire, I will give you two things. Both are of same length. Say half a meter, rubber band, rubber, one full rubber, and a steel wire of half a meter. Can you think of which is more elastic? That's the question. That's the question. No. So answer is astonishing. Definitely steel is more elastic than rubber. Even though once we apply the same force for steel and rubber, rubber elongates too much if it can withstand, if it cannot break. But steel is more elastic. How? That will learn later on. But observe now. There's a small change in the length, what I call as L, delta L. Because of the shape change, there is change in the length. There's a internal force generated inside the object due to molecules, which tries to nullify the shape change. That's what we call as elastic force, which tries to nullify the change. What that force may be called? Restoring force. It tries to restore. Therefore, once an object is deformed, once a solid is deformed, a restoring force is generated inside the spring. Sorry, inside the object, not only spring, inside the object. Then that restoring force generated per unit area inside the solid. Unit area inside the solid. Restoring force generated per unit area inside the solid is what we call as stress. It is what we call as stress. So that is the name. So if we can define the stress, how it is to be defined, it is the restoring force generated inside the object per unit area. Force per unit area. That is restoring force, stress. And what is the unit for this? SI unit. Newton per meter square, sir. Area square alva. Newton per meter square. And in fact, that is called as Pascal, unit of pressure, Newton per meter square. Is also we take that pressure, Pascal. Okay. What is the dimensional formula for pressure? ಎರಡಕ್ಕೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಮಕ್ಕಳ ರೆಸ್ಟೋರಿಂಗ್ ಫೋರ್ಸ್ ಅಂದ್ರೆ ಫೋರ್ಸೇ ಅದು ಯಾವ್ದಾರ ಆಗಿರಲಿ ಯೂನಿಟ್ ಏರಿಯಾಗೂ ಡೈಮೆನ್ಷನ್ ನಿಮ್ಗೆ ಗೊತ್ತು ಏನ್ ಬರುತ್ತೆ ಅವನು ಅದನ್ನೇ ಬರೆದಿದ್ದೆ ಈಗ ಅದೃತ. ನ್ಯೂಟನ್ಸ್ ಇದು ಫೋರ್ಸ್ಗೆನಾ ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾ ml t to the power of -2 divided by area ಏನಪ್ಪ L square. So numerator ಒಂದು L ಇದೆ, ಕೆಳಗಡೆ L square ಇದೆ. So 1 L cancels. So m L in the denominator goes to numerator means L to the power of -1 t to the power of -2. So dimensional formula for pressure or set stress ml to the power of -1 t to the power of -2 t to the power of -2. That is the dimensional formula for stress. Okay, with that, there are three types of stresses that we learn later on. And at the same time, observe carefully here. There's a change in length due to the deforming force applied. That ratio, say if the original length of this wire is L and change in the length is delta L. If we take change in length by original length, change in length by original length, what we may call it? It is called as strain. Strictly speaking, we have to call it as longitudinal strain. Longitudinal strain that we think of later on, but strain means change in length by original length. What is the unit for this strain? Unit, right? There's no unit at all because this is also measured in meter, this is also measured in meter. No dimension, no unit. Strain. In fact, once we learn stress and strain, we think of different types of stresses and strain. First type is tensile stress or longitudinal stress. One by one we'll start. Tensile stress or longitudinal stress. Longitudinal stress. What do we mean by this? Tensile stress or longitudinal stress. In fact, it is defined as normal force acting per unit area. Normal restoring force acting per unit area. Normal restoring force acting per unit area. That means, say this is the area, restoring force is F there. Why it is called as normal force? It's acting normal to the area. This is the area acting normal to that area. That's why we define this as normal restoring force. Normal restoring force per area or unit area. We write unit area. So that's what we call as the which one? Longitudinal stress or tensile stress. Corresponding strain is this one. There are three types of stress, three types of strain. Here, the change in length by original length is called as longitudinal strain. So for every stress, there is a strain. So longitudinal stress is this one, normal restoring force per unit area. And longitudinal strain is change in length by original length with this. So these are the things. Most of our time is also running short. How much? I don't know. It is not seen here.